A pleasant day to everyone. I am Jenilyn Mangahas, and for today's video, I will be reporting the introduction of Chapter 3, which is the bioenergetics, enzymes, and metabolism. For the content of my topic, I will discuss the laws of thermodynamics, free energy, coupling endergonic and exergonic reactions, the equilibrium versus steady-state metabolism, enzymes as biological catalyst, the mechanisms of enzyme catalysis, and the enzyme kinetics. So for the introduction, as we can see in the picture, it is said that you are not what you eat. So para itong isang kasabihan na hindi daw na-define ng kinakain natin kung ano yung ating identity. The human body is a machine of almost unimaginable complexity. So our body expends around 2,000 kilocalorie of energy para makapagtrabaho or para magawa natin yung mga kinakailangan nating gawin sa pang-araw-araw. And nakukuha natin itong energy na to from the food we eat. So our body performs a series of biochemical reactions to convert the nutrients from the universal currency of biological energy, at ito nga yung ATP. Itong mga reaction nito ay accompanied by enzymes that funnel the biological molecules to produce ATP for energy and para ma-build up yung mga biochemicals na kailangan natin as building blocks for our cells and tissues. And different people have very different eating habits. Meron dyang low carb, merong nagvi-vegan diet, pero ganun pa man, iba-iba man tayo ng kinakain, pero we contain the same cells and molecules, and each of us undergo of same process how these foods are converted into energy that we need for everyday work. Next is the law of thermodynamics. Bakit ba meron ditong law of thermodynamics? Ano ba ang kinalaman nito dun sa topic natin ngayon na cell and molecular biology? So sabi dyan, the study of the various type of energy transformation that occur in living organism is referred to as bioenergetics. So bioenergetics, from the word itself, it is an energy of a living organism. It is the flow and transformation of energy. How cells convert energy from various food that we eat. And energy is the capacity to do work. Siyempre, kung yung cells natin, kino-convert yung mga kinakain natin into ATP, which is the currency for energy. At itong energy na to, ito yung kailangan natin para makapagtrabaho tayo. At nakukuha nga natin ito sa mga kinakain natin. So, ibig sabihin lang, kung wala tayong energy, kung wala tayong kinakain, walang ipaprocess yung mga cells natin, and at the same time, walang mapoproduce na energy. Kasi nga, hindi tayo kumain, wala tayong kinain. And thermodynamics is the study of the changes in energy that accompany events in the universe. So, i-simplify na lang natin, katulad ng napag-aralan natin na sa thermodynamics lies in three concept. Ito nga yung concept ng work, energy, and power. So, work is the capacity, work is when we do something, and energy is the capacity to do work, and power naman is how fast natin nagagawa yung isang bagay within the period of time. So, magkakakonekta sila. Kung wala kang energy, you aren't able to do work. So, yon. Dito na tayo sa first law of thermodynamics. So, first law of thermodynamics is the law of conservation of energy. So, it states that energy can neither be created nor destroyed. So, energy can, however, converted or transduced from one form of energy into another form. So, makikita natin dyan mga example ng transduction of energy. Una na dyan ay yung windmill. 'Di ba yung windmill ay pinapagana ng wind. So pag umikot na yung blades ng windmill, meron na siyang mechanical energy kasi meron na siyang movement. Then yung mechanical energy na yon, yung pag-ikot ng blades ng windmill ay dadaan sa mga circuits ng windmill and sa generator. And then, yung mechanical energy na yon, mako-convert na into electrical energy that distributed na sa mga, for example, sa bahay, yung ganun. Nag-generate na siya ng electricity from mechanical energy to electrical energy. Next is, energy can also be restored. So, example na dyan ay yung battery, the storage of electrical energy in a chemical form. So, alam naman natin yung sa loob ng battery may chemical yan. And then, for example, yung mga laruan ng bata, pag nilagyan mo siya ng battery, nagge-generate na siya ng charge para mapagana yung certain toy na yon. And number 3, stored energy can be transported and into one place to another. So, best example niyan ay yung mga tanker. Mga tanker na nagdi-distribute ng gasolina to all over the place, all over the region. May mga laman na gasolina, i-deliver dun sa may franchise ng mga gasolinahan. So, number 4, cells are also capable of energy transduction and storage and also transport. So, yung chemical energy is stored in certain biological molecules, katulad nga nung ATP, ay kino-convert to mechanical energy when muscle contract. Ayan yung nakikita nyo, yung nagbubuhat ng dumbbell. So, the most important energy transduction in biological world is the conversion of sunlight into chemical energy, which is yun ngang nangyayari sa photosynthesis na nag-provide naman sa ng direct or indirect powers the activity of many forms of life. Diba katulad nga niyan, yung sunlight inaabsorb ng halaman, and then yung halaman naman na yon, syempre susunod naman nun i-consume ng animals o kaya ng tao. Then yung in a form of starch, pag dinigest natin yon, magiging form na siya ng glucose. Di ba, yung glucose, it also serves as yung glucose, dinadigest pa natin and magiging source of energy na. So, to discuss the energy transformation involving matter, we need to divide the universe into two parts. Ito nga yung system, which is the understudy, and the surrounding, which will refer the remainder of the universe. So, a system can be defined in various ways. It may be a certain space in the universe or a certain amount of matter. For example, a system may be a living cell. No, the change in the system energy that occur during an event are manifested in two ways. Una na dyan is the change in heat content of the system and performance of work. So even though the system may gain or lose energy, the first law of thermodynamics indicates that the lose or gain may be balanced by a corresponding gain or loss in the surrounding so that the amount in the universe will remain constant. So, ibig sabihin nito, for example, so 'di ba, imagine yung cell natin na nagre-release ng heat as it metabolizes food. So the heat lost by the cell might warm the blood and distribute that all over our body and eventually to the environment. So while the energy with the cell decreases, the energy in the environment increases naman by the same amount to ensure that the total energy remains constant or unchanged. So the energy of a system is termed the internal energy and its change during transformation is called delta E. So one way to describe the first law of thermodynamics is that delta E equals Q minus W, where Q is the heat energy and the W is the mechanical work energy. So, example dyan, uh, if a system pushes or pulls a force over a distance, then the work during that movement is W, or work is equal to force multiplied by the displacement. So, depending on the process, the internal energy of the system can be greater than, equal, or less than its energy uh, at the start, or depending on its relationship to the environment. So, ibig sabihin, in other words, change in energy can be positive, zero, or negative. So, flash on the screen is an example of a change in a system's internal energy. So, let's consider that the system is a leaf of a plant. So, during the day, inaabsorb ng chloroplast ng dahon ay ang sunlight to convert carbon dioxide into carbohydrates. So, as the cells absorbs light, its internal energy increases. Yung energy present in the universe naman ay nababawasan. So, kabaligtaran lang, reverse. Yung kapag na-absorb ng cells nung plant yung light, yung internal energy nito ay nag-i-increase, tapos yung energy naman sa universe ay nagdi-decrease. So, kabaligtaran naman ito. Sa gabi naman, at night, yung energy relationship between the cell and its surrounding is reversed. As carbohydrates produced during the day are oxidized to carbon dioxide. So, yung reaction that lose heat were termed as exothermic, and that reaction that gains heat are called endothermic. The second law of thermodynamics expresses the concept that events in the universe have direction. They tend to proceed downhill. So from the state of higher energy to lower energy. So ibig sabihin lang nito, there is a decreasing availability of energy for doing additional work. So, similar relationship for living organism, katulad nung nandun sa may libro, sa example na nandun, kapag if the giraffe browses on the leaves of the tree, or a lion preys on the giraffe, much of the chemical energy never becomes available to the animal having the meal. So, makikita nyo dyan sa picture, yung entropy o yung tinatawag nating disorder. So, the entropy of any natural and spontaneous process either increases or remains constant. So, according to the second law of thermodynamics, every event is accompanied by the increase in the entropy of the universe. So, nakikita natin dyan na example ay yung sugar cube. Kapag yung sugar cube ay placed on the container, makikita nyo sa letter A, kung mapapansin natin, yung sucrose molecules ay nasa highly ordered arrangement kung saan ang freedom of movement is restricted. Kumbaga, hindi pa siya kasi nalulusaw. Pero, habang nalulusaw yung cube, makikita natin yung sucrose movement. Yung movement ng sucrose molecules ay nag-i-increase, causing them to eventually distributed in the available space of the container. Kung makikita natin dyan, yung mga sucrose molecules, ayan na, nakadistribute na siya dun sa container. So, ibig sabihin lang nito, yung entropy of the system is at maximum. So, together, the first and second law of thermodynamics indicate that the energy of the universe remains constant, but the entropy continues to increase toward the maximum. So, the concept inherent in the first two laws were combined by the American chemist J. Willard Gibbs in 1878 into the expression delta H equals to delta G plus T and delta S, where yung Ag natin is the delta G is the change in free energy. Delta H is the change in enthalpy or total energy content of the system. T is the absolute temperature, which is Kelvin equals to degrees Celsius plus 273. And delta S is the change in the entropy of a system. So, when we arrange in this equation, total energy change is equal to the sum of the changes in useful energy and energy that is unavailable due to work. So when we rearrange and written as delta G is equal to delta H minus T delta S. So the above equation provides a measure of spontaneity of a particular process. So, sabi dito, all spontaneous energy transformation must have a negative free energy. The magnitude of free energy indicates the maximum amount of energy that can be passed on for use in another process. Processes that thermodynamically favored have a negative change in free energy were described as exergonic, and the processes that are thermodynamically unfavored have a positive change in free energy, which is termed as endergonic. So the signs of change in enthalpy and the change in the entropy for a given transformation can either be positive or negative. So, depending on the relationship between the system and its surrounding nga. So, change in enthalpy will be positive if heat is gained by the system and negative if lost. So the change in enthalpy will be positive if the system becomes more disordered and negative if becomes more ordered. So makikita natin dito, an example sa figure 3.4 ay yung water freezes. So its entropy decreases because the water molecules of ice exist in more ordered state. Sabi natin kanina, pagka more ordered state siya, ang entropy niya ay magdi-decrease. So the large number of hydrogen bonds that are found in ice make the enthalpy of water ice transition favorable, while the decrease in entropy makes the transition unfavorable. So, makikita po natin sa table 3.1 yung thermodynamics of water and ice formation. Ayan po. Tingnan na lang po natin. Nandiyan po yung temperature natin, which is degree Celsius, ano? And change in energy, change in internal energy, and change in enthalpy, and change in entropy, and yung ating change in free energy. So, free energy changes in chemical reactions. Sabi dito, all chemical reactions within the cells are reversible. According to the law of mass action, the rate of reaction is proportional to the concentration of the reactants. So, example dito ay A plus B is reversible to C plus D. So, from that equation, we can say that the rate of the forward reaction is directly proportional to the molar concentration of A and B. So, at equilibrium, the same number of A and B molecules are converted to C and D molecules per unit time as formed from them. The ratio, which is equal to K1 over K2, is termed as the equilibrium constant. So, kung makikita nyo dun sa may module natin, meron siyang formula na K1 is equal to CD over K2 A plus B. Nandun po yung formula na yon sa module, hindi ko na po naisama dito. Dissociation constant is a given measure of how much two molecules tend to stick together. So, the ratio of reactants to products present at equilibrium is determined by the relative free energy levels. So, standard free energy, ito yung delta G na may degree sa taas, basta ganon, describes the free energy released when reactants are converted to products under this standard condition. So, magkaiba po yung change in free energy at itong standard free energy change. Yung kanina po ay delta G lang, ito naman pong standard free energy change ay delta G na may degree dun sa taas niya. So, the relationship between the equilibrium constant and standard free energy changes is given by the equation change in standard free energy change equals to RT in K1 or yung ating constant equilibrium. Sa ano po ito base po dun sa libro, parang sa ano po ito, subject ng energetics. Pero ganun pa man po, ipapakita ko po sa inyo yung computation po. Meron po kasing computation na nandun po sa libro. So, sabi po dito, if the change in if the standard in free energy change is negative, the reactants will go to the right when reactants and produced are all present at 1.0 m concentration at 7 pH. So, kapag naman daw po ang tawag dito, standard free energy change natin ay positive, yung reaction naman po will proceed to the left. That is, the reverse reaction is favored. So kapag po ang standard free energy change natin ay negative, yung reaction po ay papunta po sa kanan. Kapag naman ang standard free energy change natin ay positive, yung reaction ay magpo-proceed to the left. So kabaligtaran po. So makikita po nyo dyan yung table 3.2, yung relationship ng ang tawag dito, standard free energy change and the equilibrium constant at 25 degrees Celsius. Free energy changes in metabolic reactions. So in the reaction, ATP plus H2O and ADP plus P1. Yung po yung ADP po plus PI ay yan po yung equals to ATP po yan. Yan po ay composition ng ATP. So the reaction ATP plus H2O to the ADP plus P1, the standard free energy difference between products and reactants. So hydrolysis of ATP is a highly favorable exergonic reaction that is tends toward a large ADP-ATP ratio at equilibrium. So pag sinabi po natin na ATP hydrolysis, yung hydrolysis po is the addition ng water. Ayun po, makikita po niyan sa figure 3.5. Ayan po yung reaction niya. Coupling endergonic and exergonic reactions. So, energy coupling occurs when the energy produced by one reaction or system is used to drive another reaction. So, sabi natin kanina, di ba? Negative change in free energy, yun yung exergonic, at ang positive change in free energy ay ang endergonic. So, reactions with large positive standard free energy values are typically driven by the input of energy. So, example natin dito ay yung glutamic acid plus HN3 to glutamine. So, makikita nyo dito, standard free energy change equals plus 3.4 kcal molecules. So, ito ay endergonic. This endergonic reaction takes place in the cell because glutamic acid is actually converted to glutamine into sequential actions, both of which are exergonic. So, yung first reaction natin, yung glutamic acid plus ATP to glutamyl phosphate plus adenosine diphosphate. Ang second reaction naman natin dito ay yung glutamyl phosphate plus NH3 to glutamine plus phosphate. So the bridge between these two reactions, glutamyl phosphate in this case, is called the common intermediate. Now, ito na po tayo. So, to calculate the equilibrium ratio of ADP, ATP under these conditions, we can set that change in free energy at the equilibrium value of 0 and solve the following equation. So, magkaiba po yung sinasabi ko na kanina, yung change in free energy at standard free energy change. So, change in free energy, ito po yung ating formula, change in free energy is equal to standard free energy change plus close parenthesis 1.4 kcal per mole close parenthesis log ADP PI over ATP. So, makikita nyo po dyan yung calculations. Pakisundan na lang po. Pagka po kinompute nyo yan, ang kalalabasan niyan ay 10.1 kcal per mole over 1.4 kcal per mole. So, pag dinivide nyo po yan, magiging 7.2. So, saan po nanggaling yung final answer natin na 1.6 times 10 raised to 7. So, dapat po yung logarithm natin ay isusulat po natin ng base 10. Kaya yan po ay magiging 10 raised to 7.2. Yan, pag kinumpute nyo po yan sa calculator, 10 raised to 7.2 equals, ang lalabas po dyan ay 158. So, ni-round off na lang po natin, kaya magiging 1.6 times 10. So, if a cell daw were to contain an equilibrium mixture of ATP, ADP, ito po yung ratio natin to calculate the ratio of ADP and phosphate, it wouldn't matter how much ATP was present. The cell would have no capacity to perform work. Makikita po natin dyan sa picture, the ATP hydrolysis is used to drive most endergonic processes within the cell, including chemical reactions such as just one described, yung separation of charge across a membrane, and the concentration of a solute, the movement of filaments in a muscle, and change in properties of protein. Ayan po dyan. Sa figure 3.6, makikita nyo po dyan yung few roles for ATP hydrolysis. Next is the equilibrium and steady state metabolism. So these terms were used in cellular metabolism to describe different conditions of a biochemical system. So makikita nyo dun sa may picture, as long as the amoeba can continue to take in the nutrients from the outside world, so it harvests the energy necessary to maintain concentrations of compound at a steady state. Enzymes as biological catalyst. So at the end of the 19th century, nagkaroon ng debate whether the process of ethanol formation required the presence of intact yeast cells. Involved dito sina Justus von Liebig, which argued that the reaction of fermentation that produced the alcohol were no different from the types of organic reactions. So sabi naman ni Louis Pasteur, the process of fermentation could only occur within the confines of an intact, highly organized living cell. So, after mamatay ni Louis Pasteur, yung dalawang magkapatid, si Hans and Edward Buchner, preparing yeast juice, an extract made from grinding yeast cells with sand. So, pinreserve nila yon for later use. So, after trying to preserve extract with antiseptic, nag-failed sila. And then, nag-attempt na naman sila to protect from spoilage by adding sugar. Same procedures kung paano ginagawa yung mga jam. So, instead of preserving the solution, the yeast juice produced gas from sugar and it bubbled continuously. So, after this happened, Edward Butcher discovered that fermentation produces ethanol and bubbles of carbon dioxide. So, si Hans Butcher naman shows that fermentation daw did not require the presence of intact cells. So, enzymes. Enzymes were catalysts from the Greek in yeast. Enzymes are mediator of metabolism responsible for every reaction occur in the cell. So si James Sumner obtained that enzymes are proteins. So, yung enzyme daw are proteins. So, even though enzymes are proteins, many of them are conjugated proteins. That is, they contain non-protein components called yung cofactors, which may be inorganic or organic. So, yung cofactors ay mga inorganic at yung mga coenzymes naman ay organic. Properties of enzymes. So, number one properties of enzymes are they require only in small amounts. This is because they are highly efficient catalyst. So, a single enzyme molecule can repeatedly catalyze reaction without being consumed, allowing significant biological processes with minimal enzyme concentration. Number two, they are not altered irreversibly during the course of reaction. So they are not altered. They catalyze. They temporarily bind to substrate, facilitate the reaction, and return to their original state and ready to catalyze another reaction. So, yung substrate, ito yung reactants bound by an enzyme. So, tinatawag silang substrate. The third properties of enzyme is they have no effect on the thermodynamics of reaction because they only speed up the reaction by lowering the activation energy without changing the overall energy balance. Overcoming the activation energy barrier. So, chemical transformation requires certain covalent bonds be broken within the reactants. So, reactants must contain sufficient kinetic energy that they overcome a barrier called the activation energy. So, the reactants, when they are at the crest of the energy hump and ready to be converted to products, they are said to be at the transition state. Yung mataas, yung nakikita nyo dyan sa picture, yun yung mataas na kulay pula. So, enzymes are able to lower activation energies by binding more tightly to the transition state than to the reactants, which stabilizes this activated complex, thereby increasing its energy. So, makikita natin dito sa figure 3.9, the effect of lowering activation energy on the rate of a reaction. The active site. So, enzyme substrate complex molecules form when the substrate binds to an enzyme. So, active site, part of an enzyme molecule that is directly involving in the binding the substrate. So, yung active site, ito yung binding area ng substrate. Mechanism of enzyme catalysis. So, meron ditong 3. Number 1 is the substrate orientation, changing substrate reactivity, and inducing strain in the substrate. So, the substrate orientation, kung makikita natin, yung substrate orientation has also an effect on the catalysis of an enzyme. Changing substrate reactivity, inducing strain in the substrate. So, sabi ni James Sumner ay yung enzyme daw ay proteins. So, ibig sabihin, kapag nagkaroon ng stress doon sa substrate, maaari itong maapekto sa catalysis ng enzyme. So, 3 mechanism by which enzyme accelerate reactions. Yung sa unang picture is maintaining precise substrate orientation, changing substrate reactivity by altering its electrostatic configuration and the exerting physical stress on bonds on the substrate to be broken. Next is the enzyme kinetics. So, sa enzyme kinetics, meron tayong tinatawag na Michaelis-Menten model of enzyme kinetics. So, in 1913, Leonor Michaelis and Menten reported on the mathematical relationship between substrate concentration and the velocity of enzyme reaction as measured by the rate of product formation, or also known as the velocity of the reaction. So, meron na naman tayong formula na yan to calculate the velocity or the velocity reaction of the enzyme. So V is equal to V max S over S plus Km. So according to the equation, when the substrate concentration S is set at a value equivalent to Km, then the velocity of the reaction B becomes equal to V max over 2. Makikita po natin dyan sa picture yung relationship between the rate, yung velocity of an enzyme catalyzed reaction and the substrate concentration. Next is the enzyme inhibitors. So enzyme inhibitors are molecules that are able to bind an enzyme and decrease its activity. So the cell depends on inhibitors to regulate the activity of many of its enzymes. Irreversible inhibitors are those that bind very tightly to an enzyme, often by forming a covalent bond to its amino acid residue. So makikita natin dito sa picture, competitive inhibitors are reversible inhibitors that compete with a substrate for access to active site of an enzyme. So because of their molecular similarity, competitive inhibitors are able to compete with the substrate for a binding site on the enzyme. So the effect of a competitive inhibitor depends on the relative concentration of the inhibitor and the substrate. So the image explains the effects of competitive and non-competitive inhibition on enzyme kinetics. So sa an inhibited enzyme, yung pink curve shows that the enzyme's activity without any inhibitor. So the maximum velocity or yung Vmax is at the highest point on the curve, and the substrate concentration at which the reaction is half of Vmax na tinatawag nating Km or yung Michaelis constant. Sa competitive inhibition naman, yung green curve shows the effect of a competitive inhibitor. So in competitive inhibition, the inhibitor competes with the substrate binding to the active site of the enzyme. So the increases the apparent Michaelis constant, but yung Bmax natin remains the same because the inhibition can be overcome by adding more substrate. Dun sa non-competitive inhibition naman, yung blue curve shows the effect of a non-competitive inhibitor. So in non-competitive inhibition, yung inhibitors ay nagbabinds to a different site on the enzyme, not directly competing with the substrate. So pag nangyari to, this lowers the velocity maximum, but the Km or the Michaelis constant remains unchanged because the inhibitor doesn't affect substrate binding. So, dyan na po nagtatapos ang aking video report. Thank you.